So CBR method of payment design is very important for designing the thickness of the flexible pavement. It totally depends upon, first of all, you need to understand what you mean by CBR, California Bearing Ratio Test. Okay, so for any soil that has to perform well, upon which the pavement has to be built. Okay, the CBR of the soil should have the stability. Okay, stability in the sense whatever the penetration that is going to be made upon it, that a soil should have to get the resistance to the penetration. Suppose if a plunger of 50 centimeter diameter, okay, if it is trying to penetrate into the soil mass, then that particular 50 centimeter diameter of the plunger should not be capable of penetrating into the soil. Then only the soil is said to have the maximum value of CBR. Suppose if the plunger is going to be easily piercing or penetrating into the soil mass, okay, with the deepest depth, okay, then you can assume the CBR value of that soil is very less. So as far as possible, for any kind of pavement to be built upon any kind of soil, the CBR of that particular soil should be more. Okay, as I will be telling you with respect to the two different types of soil. One is with respect to moram, another is with respect to the black bottom soil. Wherein in the black bottom soil, the value of the CBR is very less compared to the value of CBR that we are referring with respect to what you can say moram, right? Now, in 1928, California Division of Highways in the USA developed the CBR method for pavement design. So, when it has been initiated, so as per the history of the CBR method, it says that this was been developed by the California Division of Highways in the USA during the year 1928. Okay, they have initiated this CBR method for pavement design. We are going to look at this particular CBR method in detail with coming slides. Okay, the majority of the design curves developed later are based on the original curves proposed by O.J. Porter. So the name of scientist is O.J. Porter, who has initiated the original curves of CBR. Later, the majority of the design curves are going to be developed or has been developed based on the original curves that was being developed by O.J. Porter. Okay, at the beginning of the Second World War, the corps engineers of USA made the survey of existing method of pavement design and adopted CBR method for designing the military airports. So for any design of airports, either it might be a domestic airport or an international airport or any kind of a military airports, the CBR method has considered to be a very most important type of methodology for designing the pavement. Okay, so at the beginning of Second World War, the Corps Engineer of USA made a survey of existing method of pavement design and adopted CBR method for designing the military airport pavements. So the what does the statement says? During Second World War, as you know that there must be a very many number of military vehicles or military operations that are going to be done upon the road payments. Like say for example, if any road is going to be constructed, suppose especially if we are trying to consider the national highway, then it has to be built as per the criteria of allowing the military vehicles to run upon it. Military vehicle in the sense, just say for example 8 tons. 8-ton load means what? So it is that military vehicle, minimum weight of a military vehicle that could come over the road surface, and that particular national highway should also be capable of allowing all the military vehicles to run upon the road surface such that the road should not get damaged. In the same manner, if any military operations are going to be carried out, okay, upon the roads or it might be upon the airports, okay. So during the Second World War, what they used to do? They used to carry the bombers. They used to carry the rockets. They used to carry weaponologies. They used to carry tankers with respect to what you can say the aircrafts. While it was landing as well as takeoff, the payment would have been ruptured. So ultimately, the soil should have been very much stable to cater the service for all these military operations, or what you can say the aircraft that are going to be taking off or else landing down. So they had developed the CBR curves, okay, California Bearing Ratio Test curves, based on which the thickness of the pavement would have been designed. We are going to look at the different types of curves on what basis they have developed in the later slides. Okay, one of the chief advantages of the CBR method is the simplicity of the test procedure. Okay, uh, how this particular CBR method is going to be very much simple during its what you can say implicity. Okay, we are going to look at the later stage. Okay, the CBR tests were carried out by the California State of Highway Department on existing pavement layers, including subgrade, subbase, base course. On what layers the CBR test is going to be adopted? It is adopted for the three layers. Either it might be on subgrade, subbase, or else base course. So, what does this CBR is going to indicate us? The based on the value of the CBR test, we will be able to conclude what should be the thickness of a flexible pavement that has to be provided for the considered pavement. Either it might be a flexible pavement or else say suppose it might be a bituminous concrete pavement. Okay, based on the extensive CBR test data collected on the pavement which behaved satisfactorily and those which failed, an empirical design chart was been developed correlating the CBR value and the pavement thickness. So they have consistently tested the various different types of pavements. Okay, where some of the CBR tests were been failing and some of the CBR tests were been passing satisfactorily depending upon the thicknesses. Okay, suppose for example I would like to quote you, if the pavement thickness is very less, when are you going to expect the thickness of the pavement is going to be less? Wherever the CBR value of the soil is going to be greater, then you can expect to have the lesser thickness of the pavement. Thereby you are going to assume the cost of construction of that particular pavement is going to be reducing. Okay, but wherever the CBR of the soil is going to be more, wherever the CBR of the soil is going to be more, thereby you can expect or assume the thickness of the pavement to be less. Okay, the thickness of the pavement can be assumed to be having lesser thickness. Why? Because you know that in other words, as and when the value of the CBR is going to increase, the thickness requirement of flexible pavement is going to get decreased. As and when the CBR of the soil is going to decrease, okay, the thickness requirement of flexible pavement increases. With the increase in the thickness, the cost of construction increases. With the reduction in the thickness, the cost of construction reduces. Okay, so on what basis we can correlate this data? Based on the value of the CBR of the soil as well as the pavement thickness. They have correlated different types of curves where the pavements have been failing or the pavements are going to be satisfactorily serving the needs of what you can say the either traffic operation, either it might be a military operation or it might be a domestic operation. So the basis of the design chart is that a material with a given CBR required a certain thickness of pavement layer as a cover. So for a given thick, say for example, if I would like to tell you the CBR of 2%, CBR of 3%, CBR of 4%, say for example, a CBR of the soil is going to get ranged from 2% till 10%. So for any different value of the CBR, we will be able to conclude what should be the thickness requirement of a flexible pavement for a given desired value of CBR in terms of percentage. Say if for example 2% of CBR the soil requires depth of pavement layer for example 200 mm for example. Okay, 10% of CBR of the soil requires 100 mm. So what does it mean? So when you are referring with respect to 2% of CBR as well as 10% of CBR, the thickness which has been considered initially of 200 mm has got reduced to 100 mm. So in that particular manner, they have designed different types of curves, or the design chart has been prepared based on the material of the soil with having different CBR values, so as to ascertain what should be the design thickness of the pavement layer that has to be constructed over the subgrade. Okay, so what should be the different types of sub base layer, what should be the different types of base course layer, we have to assume it based on the value of the CBR that we have to get it from the soil mass. So what you have to understand from the CBR initially in for your rough understanding, it is what can say the strength that is going to be possessed by the soil mass. It is nothing but the resistance that is going to be offered by the soil for penetration. Okay, during the penetration, whatever the load that is going to make over the soil mass, the soil should be able to capable of withstanding the load or sustain the stresses that could come over the pavement surface. Okay, the higher load needs a thicker pavement layer to protect the subgrade. It is a common sense to understand whatever the higher loads that are going to come over the road pavement, usually we are going to expect the pavement to have the thicker layer. Okay, so it is not necessarily like, for example, if you go on increasing the loads of a vehicles, you are likely to increase the thickness of pavement continuously. Say, for example, the two-wheelers, okay, compared to four-wheeler, the load is going to be lesser. Okay, compared to four-wheeler, if you are going to refer to many number of different axle loads of a trucks, then what you can say, the load is completely higher than two-wheeler but lesser than the trucks. Okay, so in other words, if due to the heterogeneous traffic that could come over the road surface, if the loads are going to get increased day by day, so are you going to go increasing the thickness of the pavement continuously? That is why it is not what you can say made routine practice for increasing the thickness of a pavement with the increase in the loads. So they are going to restrict the load rather than increasing the thickness of the pavement continuously. They are trying to restrict the, what you can say, the load of the standard axle load of 8 tons. So they are trying to restrict the load of 8 tons, means the pavement thickness could be constant. Okay, it may not be continuously increasing, nor it might be decreasing. So hence the major importance of this pavement is to protect the subgrade soil. I know that, or we know that, the subgrade is very weak in, or you can say the load bearing capacity. Okay, hence you are trying to construct the pavement layers above the subgrade. Okay, in the form of different types of layers like subbase, base course, and surface layer. Okay, and you also know the inferiority and superiority of the different types of materials. You know, superiority of quality of material is going to be laid at the top, and inferior quality material you can expect to see at the subbase as well as subgrade. Okay, subgrade is nothing but locally available material or locally available soil that is been routinely available with us during the construction of the pavement. Either it might be a weaker soil or it might be a stronger soil. Okay, if the weak soil is going to be met with during the time of construction, it has to be stabilized well. Okay, before the road construction is going to be carried out. Otherwise, the cost of construction of that particular pavement is going to get increased in terms of increased thickness. Okay, so hence we have to first of all stabilize the subgrade soil. It totally again depends upon how to subgrade, how to stabilize the subgrade soil, how to destabilize the subgrade soil. It again refers with respect to the value of the CBR. Okay, design curves correlating the CBR value with the total pavement thickness cover were developed by California State Highway Department for wheel loads of 3175 kg and 5443 kg, representing lightweight traffic as well as heavyweight traffic. For lightweight traffic of 3175 kg as well as heavy traffic 5443 kg, the CBR values as well as total pavement thickness curves were being developed, correlating what? The value of the CBR with respect to the total pavement thickness for a load of 3175 as well as 544 kg, which were being considered as light traffic as well as heavy traffic during those days. Later, the design curves for 4082 kg wheel load was been obtained by interpolating for medium traffic. In between this 3175 as well as 5443 kg, we have interpolated the value to get the value of 4082 kg, such that the design curves of the CBR were been obtained for the wheel loads of 4082 kg. Okay, so what I mean to say, for different loads that could come over the road, we have to know what is the value of CBR of the soil. For that particular percentage of CBR of soil, we have to correlate the desired thickness of the flexible pavement that is required for construction of pavement. Okay, it totally depends upon the load as well as the percentage of CBR. Okay, which you want to see at a later stage. Studies carried out by US Corps of Engineers have shown that there exists a relationship between pavement thickness. Here you can see the expression wherein what you can say, the legends say T is nothing but the pavement thickness, which is going to be referred in terms of centimeters, and capital P is the wheel load in terms of kg. Okay, and here this is the CBR, California bearing ratio, which is going to be expressed in terms of percentage. It doesn't have any unit other than the percentage, and this is small p. You can refer this to be of small p here. Small p is nothing but what? A tire pressure. Already know what you mean by tire pressure. That is expressed in terms of kg per centimeter square. And capital A is area of the contact. Area of the contact made by the wheel upon the pavement surface, that is represented in the form of a circular in shape, which is expressed in terms of centimeter square. Okay, so here they are expressing the relationship that is existing between the pavement thickness. With respect to this formula, you can refer. It is no, there is an existence of a relationship between the pavement thickness, wheel load, as well as the tire pressure and the value of the CBR within the range of 10 to 12%. Okay, so, studies carried out by US Corps of Engineers have shown that there exists a relationship between pavement thickness, wheel load, tire pressure, as well as CBR value within the range of 10 to 12%. So, what does it say? This formula is going to be applicable only for the CBR of the subgrade soil, which is going to have a range of 10 to 12%. So, this is applicable only for those soil whose value of the CBR is lesser than 12%, right? That is a major note that you have to make it out from the studies which are going to be carried out by US Corps of Engineers. Therefore, it is possible to extend the CBR design curves for various loading conditions using the expression. So, for different loading conditions, you can extend the CBR curves. I just told you with respect to this 3175 kg as well as 5443 kg. The California State Highway Department have developed what can say design curves for the CBR value, correlating CBR value as well as total pavement thickness. But later, US Corps of Engineers they have shown the relationship between the different parameters whose value of the CBR range happen to be in between 10 to 12%. So you can also extend what can say the CBR design curves for various different loading conditions beyond what you can say 4082 also, or 5443 also, or 3175 with respect to this expression, provided that the value of CBR is lesser than 12%. But what could be varied? Variable is P. Depends upon the variable capital P. You can just decide the thickness of the flexible pavement for different values of CBR in the range of 2 to 12%. So with the varied wheel load within the range of 2 to 10 to 12%, up to a range of 10 to 12%, like say for example 2 4 2 3 4 5 6, so on up to 10 to 12%. Okay, we can easily design the thickness of a flexible pavement with this expression, where A was happened to be area of a contact made by the wheel. Tire pressure will be known. Area of the contact made by the wheel upon the pavement surface will be known. CBR till the 10 to 12% will be known starting from 2%, and wheel loads variable is going to be also known for a given wheel load. Should the thickness of the flexible pavement could be calculated with this expression. Okay, this is the design chart shown by California State Highway Division. CSHD means California State Highway Division have developed the design chart for the three different types of traffic condition. One is heavy traffic, that is which we had discussed here. Look at this point. So 3175 kg was a light traffic here. Okay, see here 3175, it's a light traffic curve. Okay, and here 5443 kg was considered to be a heavy traffic. 55, so it should be you can make a correction over here. 5443, it's rather 5543, it should be 5543 instead of 5443. You can consider this one to be 5543. And the medium traffic which we had obtained is the interpolated value between 3175 and 5443 happened to be 4082 kg. 4082 is for medium traffic, the middle curve which we are going to see. Along x-axis we have the CBR variable that is going to be getting changing from 2% to 12%. Okay, and beyond 20% to 80% are being correlated. Okay, so what we have seen, the US Corps of Engineers as well as California Division of Highways, they have given these curves for light, medium as well as heavy traffic for the range of CBR that are varying from 2, 3, 4, 5, 6, so on up to 10 to 12%. But later it could be means no extrapolated for many number of different percentage of CBR. Okay, say for example 20, 30, 40, 50, 60, 80, depending upon the previous curves which has been shown by what you can say design chart. within the range of 12%. See, along negative axis you have the pavement thickness, along positive x-axis we have the CBR in terms of percentage. Based on the different traffic conditions, we can easily, by knowing the value of the CBR in terms of percentage, say for example, I will be giving the soil is having high CBR 3%. Soil is having a CBR of 3% for a light traffic condition. What is the pavement thickness? So directly you can just cut this particular curve which is having a light traffic condition and take it towards negative y-axis, so that you can get the thickness of pavement which is in the range of 400 mm to 500 mm. Okay. So what are the two parameters that are required? One is the loading condition as well as the other is the CBR in terms of percent. Already you know how to find out the value of the CBR in terms of percentage, which you have studied in the previous semesters during concrete highway metal slab. Have you all done that exercise or not? Have you done the practical on conducting this CBR test? Yes or no? That is a prerequisite for understanding what you mean by CBR in terms of percentage. How are we going to get the value of CBR in terms of percentage? Okay, that is a prerequisite as well as abstract of that particular experiment to obtain the value of CBR of the soil. Later on, we can correlate to get the thickness of the pavement based on what you can say allowable limit of the traffic, either light, medium, or heavy. Now, we are going to discuss about the pavement thickness determination by IRC. Okay, pavement thickness determination is called as CBR design chart recommended by IRC. IRC is nothing but an Indian Road Congress. So what this IRC has done is, there is nothing much difference what we can assume for the design chart that has been given by California State Highway Division. Okay, here along x-axis there is a CBR in percentage. Along y-axis there is a depth of construction of the flexible pavement. Depth in the sense, again, it is nothing but the thickness of the flexible pavement. But what the recommendation of IRC has made is, they have given you the number of vehicles per day exceeding 30 kilonewton laden weight. So what is the difference? For all the vehicles that are measuring a load of 30 kilonewton or more, for all the vehicles, total number of vehicles per day, those are exceeding the weight of 30 kilonewton or more than that. Okay, laden weight that is going to be coming over the road pavement, that have been classified in terms of design curves A, B, C, D, E, F, G. Say suppose the number of traffic, there are 0 to 15 for acre, which you are going to refer, the number of vehicles per day that are exceeding 30 km laden weight are only in the range of 0 to 15. Say for curve V, the number of vehicles per day exceeding 30 km laden weight are 15 to 45. There is a traffic classification which you can make out for different curves like A, B, C, D, E, F, G. Say for the traffic that is exceeding beyond total number of vehicles that are exceeding 4500 kg, say not 4500 kg, sorry, it's a count, total number of vehicles. They are nothing but the count of vehicles, number of vehicles. If they are greater than 4500 kg, 4500 numbers, okay, then you can refer to the curve G. So, but these 4500 number of vehicles should have to exceed the laden weight of 30 kilonewton. 30 kilonewton in the sense, at least minimum of 3 tons or greater than 3 tons of load has to be ascertained for counting the traffic that could be coming over the road surface based on the different types of design curves. Okay, with respect to the different value of CBR in terms of percentage. Okay, again, say suppose if you are going to refer to the value of CBR as 3%, cut this curve A for the design curve for the 15 number of vehicles that are exceeding 3 tons for 3% of CBR. What is the pavement thickness that is required? It is in the range of 300 to 400. Okay, it is in the range of 300 mm to 400 mm. That is 30 centimeters or 40 centimeters. So in that way, you can easily find out what you can say the design thickness of flexible pavement either by CSHT method or IRC method. So in order to design a pavement by CBR method, okay, first the soaked CBR value of the soil separate is evaluated. What do you mean by soaked and what do you mean by unsoaked? So if you are going to keep the soil mass for 4 days in the water, okay, if you are going to represent the CBR in terms of percentage after soaking the soil in the water for 4 days, if you are going to test that particular soil mass for CBR determination, then it will be called as soak CBR value. Obviously, the value of the soak CBR value will be lesser compared to the unsoaked value. So usually, why we are going to conduct the soak CBR value? Wherever we are constructing the road in the waterlogging areas, wherever the water table of the particular area is going to be higher, there it is mandatory for us to collect the soil mass for doing the soak CBR test. Okay, such that we'll be knowing what will be the strength possessed by the soil in the worst condition. Even in the worst condition, whenever it is coming in contact with the water, what will be the position of bearing capacity of that particular soil, how well that soil is going to behave during the moisture that is going to be absorbed by that particular subgrade. Okay, so hence in order to design a pavement by CBR method, first the soak CBR value of the soil subgrade is going to be evaluated. Then the appropriate design curve is chosen by taking the design wheel load as given in the above figure, or by taking the anticipated traffic into the consideration as shown in the below figure. Thus, the total thickness of flexible pavement needed to cover the subgrade of known CBR value is going to be optimal. That's what I told you. With the known value of the CBR in percentage, as well as the different types of traffic classification or the different loading condition, you could be able to find out what is the depth of construction. So, thus, the CBR method of flexible pavement design is based on strength parameter of subgrade soil and subsequent pavement material. Okay, what do you mean by this? The CBR method of flexible pavement design is based on the strength parameter of subgrade soil as well as subsequent pavement material. What type of pavement material that you are going to lay above the soil subgrade, it also matters. Suppose if the CBR of the subgrade soil is greater, but the material that you are going to make use for the construction of pavement is very weak, then the pavement is going to get failed. You are not going to blame that the CBR of the subgrade soil is weak, because it is not because of the CBR of the subgrade soil. It is because of the improper material or improper pavement material, or what can say inferior quality of the pavement material that has been laid over the subgrade soil, or it might be because of poor CBR soil, uh, superior quality of material, pavement material that has been laid. Okay, neither it should be a poor what can say a poor value of the CBR of the subgrade with respect to the superior quality of material that has to be laid, or nor it should be greater value of the CBR of the subgrade soil with the inferior quality of the pavement material that is going to be laid over the subgrade soil. It should be such that superior quality of material that is to be laid over the soil subgrade with suitable percentage of CBR that has to sustain the loads that could come over the road surface. Okay, thus that the stresses, strains, as well as the deflections that could get transferred to the lower layers should be within the permissible limit, thus that this subgrade soil should not get filled beyond beyond the bearing capacity. IRC recommendations for the CBR method of design, we are referring to old method, that is IRC 37 1970. So here some of the important points recommended by the IRC for the CBR method for design curves are given below. CBR test should be performed on remolded soils in the laboratory. What do you mean by remolded soils? We are going to collect the soil mass from the site by digging the earth at suitable depth, say 3 feet, okay, or whatever the depth at which the subgrade soil is going to be obtained. We are going to core cut and get the remote soil in the laboratory. In situ tests are not recommended for design purposes. In situ in the sense at a practical site condition, then and there itself, if you are trying to measure CBR test, then it is not what you can say permitted. It is not what you can say practically suited for recommending the design purpose. Okay, so what you should do, you have to collect the soil sample to the laboratory itself for testing the CBR in terms of percentage. The specimens should be prepared by static compaction wherever possible, and otherwise by the dynamic compaction. You know what you mean by static and dynamic. Again, you should not repeat it. So depending upon the number of blows given by the rammer, either it might be 25 or 56, light compaction method or heavy compaction method, totally depends up. the different types of weights with which the ram is going to fall upon the soil surface. Either it can be called a static compaction or dynamic compaction. The standard test procedure should be strictly adhered to. So what does this IS-37 indicates is, especially 1970, means they are recommending the soils to be tested in the laboratory by either static compaction or by dynamic compaction. Okay, and also for the design of new roads, the subgrade soil sample should be compared at the OMC. Okay, they have given the test procedure how to conduct the CBR test as per the guidelines. You know that usually there is a practice of making that soil that has been corrected or collected. The CBR of that particular soil should be tested at the OMC. At the desired OMC, we are going to obtain the maximum dry density. Okay, so we have to first of all mix the suitable water content, which is going to be called as optimum moisture content, to the soil, and thoroughly mix that soil and take that particular soil into the test specimen for testing the soil for getting the obtainable result of CBR in terms of percentage. Okay, so that is what they had said. We should not forget the OMC as well as MDD during the test of CBR percent, especially as the decision says that for the design of new roads, subgrade soil samples should be compared at OMC to proctor density wherever suitable compaction equipment is available to achieve this density in the field. Otherwise, the soil sample may be compacted to the dry density expected to be achieved in the field. In the case of existing roads, the sample should be compacted to the field density of a subgrade soil. So what does it mean? For any type of a soil subgrade, okay, during the time of compaction, they should have to lay the water before the compaction process is going to be carried out. They should have to lay the water through the tanker. Have you not seen the water is going to be laid upon the soil subgrade before the compaction? It is because that whatever the test which we are conducting in the laboratory, by mixing the water to the soil, we are going to note down at which particular optimum moisture content we are going to obtain the maximum dry density. That quantity of water should be laid at the practical site to obtain the maximum dry density. That is why they are going to lay the water at the practical site condition before the roller is going to be rolled over the road surface. They have going to moisten the soil. Okay. In the new construction, the CBR test specimen may be soaked in water for 4 days before testing. However, in the areas of arid climate or when the annual rainfall is lesser than 50 centimeters and the water table is too deep to affect the subgrade adversely, and when the thick impermeable bituminous surface is provided, it is not necessary to soak the soil specimen before carrying out the CBR test. Wherever possible, the most adverse moisture condition of the subgrade should be determined from the field. So what does it mean? If with respect to the annual rainfall, if it is lesser than 50 centimeter, then it is not recommended to have the soak CBR test of the soil sample. Or wherever the water table is too deep to affect the subgrade, then it is also not permitted to go for the soak CBR. And again, if the pavement thickness is or the bituminous surfacing provided is impermeable and it is going to be very much thicker, then again we are not going to go for the soak CBR, because if thickness of the flexible pavement or the bituminous surface increases, then water cannot get penetrate into the pavement as well as reach to the soil subgrade. And it's a usual practice to have the test of average of 3 test samples should be taken for determination of the CBR in terms of percentage for getting the what you can say desired maximum density at required optimum moisture content. Okay, if the maximum variation of the CBR value of 3 specimen exceeds the specified limits, the CBR should be the average of at least 6 samples. The specified limits of maximum variation in the CBR are 3%. Okay, for the CBR values up to 10%, 5% for values 10 to 30%, 10% for the values 30 to 60%. So what is allowable? The maximum variation that is permissible for the CBR up to 10% is 3%. So the average of 3 samples should have the variation of 3%. If it is beyond 3% for the CBR value up to 10%, you have to go for testing 6 specimen. For the value of the CBR 5%, say for the value of the CBR in between 10 to 30%, the variations allowed are 5%. If the variation is going to go beyond 5%, then instead of taking the average of 3 specimens, you have to go for testing the 6 number of samples, okay, to get the average. Okay, this is again the variation is allowed up to 10% for the CBR value in the range of 30 to 60%. Okay, the top 50 centimeter of the subgrade should be compact at least up to 95 to 100% of water density. So usually, as per the statement itself says that a top 50 centimeter of subgrade should be compact at least up to 95 to 100% of water density. Is understood. An estimate of the traffic to be carried by the road pavements at the end of expected life should be made keeping in view the existing traffic and probable growth of the traffic at the later stage. The pavements of the major roads should be designed at least for 10 years life period, and the following formula may be used in such cases for estimating a design traffic. So it is preferably a routine practice to have not only for the expected say existing traffic should not be also taken. Along with this existing traffic, we should also take the anticipated traffic or the probable growth of the increased rate of traffic that could come in the future should also be taken into view. And the design of a pavement should be such that the design life of the pavement should be carrying the traffic up to a design period of 10 years, at least 10 years. Okay, you have to take that into our consideration. Design life of pavement should cater service for up to 10 years, and the traffic condition should not be of only existing condition. It should also be taking care of anticipated traffic growth of the uh, what you can say automobiles that could come over the road surface, depending upon which the thickness requirement flexible pavement is going to get varied based on what the traffic as well as design life of pavement, and also the CBR values that could get ranged from uh, weaker soil towards stronger soil. Okay, we'll be talking about the solution to the problem in the next class itself. I think there is only 2 minutes to go. This is the formula by means or the virtue of which we'll be able to calculate the what can say the CBR value of the soil subgrade with reference to the different types of curves. How are you going to determine the what can say the design thickness of flexible pavement using the value of the CBR and using the value of the different what can say data, like say for example there is a correlation of what can say correlation of what I told you, the correlation of the wheel load, CBR, tire pressure, area of the contact to determine the pavement thickness, right? So hence, with all the correlated parameters, okay, if they have been given you the data of correlated parameters, we can usually easily determine the design thickness of the flexible pavement. This is an example which we are going to learn in the next class. Okay, it's very important formula which you have to remember. If in the examination they are going to ask you to design the thickness of flexible pavement based on CBR, then with the simplest or can say substitution, you can easily determine the thickness. Okay, and I asked you people to go through the Burmese as well as Bosniaks following assumptions as well as its limitations. Okay, everything is there in the slide itself. These are the limitations of the Burmester. Okay, which is going to be obtained at the end of the slide. Okay, so with this we have completed the what you can say the CBR test of what you can say the design of the pavement by the CBR, either by IRC old method or by California Division Highway method or by US Corps of Engineers method. Okay, so we're going to look at the problem section in the next class.